Hi students, this is AJ sir. Let's study 10th standard ICSE Math, Chapter 20A, Surface Area and Volume, Cylinders and Hollow Cylinders. Before we start with exercise 20A, we must learn these formulae. For a cylinder, you can see that the top and the bottom are circles and the lateral side is a curved surface. If I open it up, it will look like a rectangle. So if this is a cylinder, it's a hollow cylinder by the way. If I open it, the curved surface area is nothing but a rectangle. The area of cross section, that is a slice of this cylinder, is a circle. So that's pi r squared. The perimeter of this cross section, this edge, is the circumference, which is 2 pi r. The curved surface area, that is this portion, curved area, so not including the top circle area and the bottom circle area, only the curved surface area, formula is 2 pi r h, where h is the height. The total surface area, that is the curved surface area, plus the top circle, plus the bottom circle, will be 2 pi r h plus pi r square plus pi r squared. So together we can say it's 2 pi r h plus r. The volume of the cylinder is pi r square into h. This was a solid cylinder, that is, it is not hollow, it is filled with metal or any material. What if the cylinder was hollow, something like this? That means it has some thickness. That means it has external curved surface area as well as internal curved surface area. If you want to paint it, we'll have to paint it from the inside also. The top part is not a circle now, it's a ring. You can actually put your hand through it. It's hollow from inside. So there is a ring on top which needs to be painted as well, and there will be a ring at the bottom as well. So the thickness of the wall, this thickness is capital R minus small r, where capital R is the radius of this big circle and small r is the radius of this small circle. So that's the thickness. The area of the cross section, that is, if I cut a slice of it, what will I get? I won't get a circle, I'll get a ring, the shaded portion, because the central part is a hollow. So that ring area is nothing but area of the big circle minus area of the small circle, which comes up to be pi r square minus pi r squared, which is this area of a ring. Now the external curved surface area, if you are painting only the outside part, not the top and the bottom, okay, only the curved surface area, the formula for that is 2 pi r h. And the internal curved surface area, if you are painting the internal part of a cylinder, that is 2 pi r h, small r, because the smaller circle is involved here. H remains the same, of course, h is same. So the total surface area, that is the external CSA, the internal CSA, the top ring, the bottom ring, everything included will be 2 pi r h plus 2 pi r h plus 2 pi r square minus r squared. That is a combination of these three. But while calculating, you know what you should do in the next step? Remove 2 pi common and then solve. That will make calculations easy. Don't substitute pi here and here and here and solve separately and get decimal answers and then add. That's a headache. What about volume of the material? That is the volume of only the thickness. We don't have to calculate the volume of the air inside it. So the volume of the material, let's say it's made up of steel. So the volume of the steel is the total volume of the large cylinder minus the internal volume, which is filled with air. Can you see the small cylinder inside? It is not made up of steel, it is filled with air. So we won't count that. So the external volume minus internal volume is pi r square h minus pi r square h, and remove pi common, of course. So if you know these formulae, then the sums become very easy for 20a. No cancellations in 20a. Let's start with the third sum. A cylinder of circumference 8 centimeters and length 21 centimeters rolls without sliding for 4.5 seconds. Now, if the cylinder rolls once, what is the distance it travels? Look at this cylinder. It starts from here. It completes one roll, and I get back to the starting point, which was here. So how much distance did it travel? Well, it traveled distance equal to the circumference, isn't it? The distance traveled in one roll is nothing but its circumference. And how much area did it cover? Suppose the roller is on the pitch of a cricket ground. So how much area did it flatten in one roll? That is equal to the curved surface area. This is the curved surface area. That is the area covered in one roll. And they are saying that they complete 9 rounds per second. And they're asking in 4.5 seconds how much distance is covered and how much area is covered. Okay. First of all, distance traveled in one roll is nothing but the circumference, which is 8 centimeters. So the distance traveled in 9 rolls will be obviously 9 into 8, 72 centimeters. Now we'll use unitary method. See, the 9 rolls were completed in 1 second. That means the 72 centimeters were covered in 1 second. In 1 second, the distance covered is 72 centimeters. So in 4.5 seconds, how much distance will be covered? Cross multiply and get the answer. Next, Roman number 2. Circumference is 8. That means 2 pi r is 8. Let's find the curved surface area. The curved surface area is 2 pi r h. But we know the value of 2 pi r, which is 8, and height is 21, which is mentioned as length in the question. Same thing. So the total curved surface area is 168 centimeters squared. Remember, area is in square. We could have found radius first and then substituted, but that was unnecessary, so we did it directly. Now we know that the area covered in one roll is nothing but the CSA, which is 168. So the area covered in 9 rolls will be 9 into 168. Don't multiply this yet. Always postpone your multiplication division, hoping that in the future something might get cancelled. Now 9 rolls were covered in 1 second. That means so much area was covered in 1 second. Then in 4.5 seconds, how much area was covered? Don't use x again, use y. Well, cross multiply and the answer is 6804 centimeters squared. Well, nothing got cancelled except for 2 and 168. That's okay, no harm done. This is the final answer. Don't forget the units. The volume is in cube, area is in square, and length, radii are in centimeters, meters only. Now the fifth question. What length of a solid cylinder, 2 centimeters in diameter, 2 centimeters means radius is 1 centimeter, and solid cylinder, must be taken to recast it, that means melt it and create a new cylinder out of it, into a hollow cylinder, and now the diameter is 20 centimeters external diameter, and it is 0.25 centimeters thick and 15 centimeters long. So the hollow cylinder looks like this. Now what if the external diameter is 20? That means the radius is 10. And the thickness they have given as 0.25. So now tell me, what is the internal radius? The external radius is 10 centimeters. So the internal radius will be 10 minus 0.25, which is 9.75. So we got capital R, we have small r, we have h also. Good job. Now, since it's a recast sum, we can say that the volume of the solid cylinder is equal to volume of the hollow cylinder. Obviously, the volume will remain the same. Imagine the solid cylinder was made up of steel, and if you melt it and you make anything out of it, the volume of the steel will remain the same. The shape and size will change, but the volume, the amount of matter, will remain the same. In fact, even the mass will remain the same. Now, volume of solid cylinder formula, we know pi r square h. I have intentionally used capital R and capital H to distinguish it from this r and this h. And the radius of the solid cylinder is already given. It's 1 centimeter. Actually, they give diameter as 2 centimeters. So we know that radius is 1 centimeters. Height we don't know. That's what we have to find out. They've asked for length. It's the same thing. And volume of hollow cylinder formula is this. I'm writing R1 square minus R2 squared into H. Good news. Pi gets cancelled. In many sums this will happen. Many sums. So don't forget it. This will make our calculation easier. Substitute all the values. Don't do 100 minus whatever. Instead use the formula a square minus b square is a plus b, a minus b. Yet another trick to make your calculations easy. I want the value of h. So you simply multiply this and you get the value of h in centimeters. Next, the seventh sum. A metal pipe has a bore that is inner diameter of 5 centimeters, inner diameter. And it is 5 millimeters thick all round. 5 millimeter means 0.5 centimeters. That means capital R will be 5.5, isn't it? Small r will be 5 and capital R will be 5.5. If you want to draw a diagram to figure it out, you can. Find the weight. Actually, they mean mass. In kilogram of 2 meters of the pipe. So the height or the length is 2 meters. That is 200 centimeters. Make sure all units are same. If you don't convert millimeter into centimeter or meter into centimeter, you'll get a wrong answer and you lose marks. So be careful about units. And they've given the density. They're saying 1 centimeter cube weighs 7.7 grams. So we'll use unitary method later on. But first, let's find the volume. Because volume into density will give you the mass. So R2, that is the internal radius, is 2.5 centimeters. Okay, so they had given the diameter, so we had to divide it by 2. Okay. And the external radius, we'll have to add the thickness, that is 0.5, so that is 3 centimeters. Height also we know, so now use the formula to find the volume. Again, see how I'm calculating, and always take pi as 22 upon 7. Only if they mention in the question to take 3.14, only then you're allowed to do that, otherwise not. A plus b, a minus b, calculate. What I'm going to do is I'll multiply this first because this gives me 100. And this I'll write as 11 upon 2. 2 cut 11, that's 121. And now I've exhausted all my tricks. Now we have no choice, we'll have to divide it. Or maybe not. Keep it as it is. Who knows, in the future something may get cancelled. Now unitary method. They said 1 centimeter cube volume has a mass of this much. They used weight, but I'm using mass. Because it's scientifically correct to say mass, not weight. Weight is the gravitational force acting. Weight is measured in gram force or Newton, not in grams. So if volume is this much, mass is how much? Cross multiply, and I was right, something can get cancelled. So 77 upon 10, cut 11, 0, cut this into 11, 13310. See, you should calculate so fast. And then divide by, no division, this is the answer, gram. But did they mention to convert it to kg? Oh yes, they mentioned that. So don't forget to convert it to kg in the end, dividing by 1000. Let us shift the decimal 3 places. 1, 2, 3. Next, 9th question. A cylindrical container with internal radius of its base as 10 centimeters contains water up to a height of 7 centimeters. Find the area of the wet surface of the cylinder. So imagine this is a diagram. The internal radius is 10, okay, and the height is 7. The total height doesn't matter, and the external radius also doesn't matter. We just have to find the surface area which will get wet. Ignore the cube out here. Now I can see that the curved surface area will get wet, and even the bottom floor, the base will get wet. The top won't get wet, of course. So the area of the wet surface is the curved surface area, where this is the R and this is the H, plus the area of the base, which is a circle. So area of wet surface is CSA plus area of base, 2 pi RH plus pi R squared. Remove pi R common, it will be easy for calculation purposes. Substitute the values and you get this as the answer. So a lot of division and multiplication, which is time consuming, but you need practice, so don't copy, do it on your own. Next, 11th sum. The height and the radius of the base of a cylinder are in the ratio 3:1. Okay, then we can assume radius to be x and height to be 3x. Its volume is also given in terms of pi. Good. Find the total surface area. So let the height be 3x and radius is x. Volume is given, but volume is pi r square h. Good news, pi got cancelled. That's a big headache relieved. R is actually x, so r square will be x squared into height is 3x. X square into x is x cube. 3 goes down, I get 343 by division. Cube becomes cube root. Cube root of this is 7. If x is 7, then we can get the value of height and radius. Once we get h and r, we can find the total surface area using the formula. That is what they have asked. Next, 13th sum. The radius of a solid right circular cylinder is decreased by 20%. That means it became 80% of the original. And its height increases by 10%. That means the height has become 110% of the original. Find the percentage change in its volume and its curved surface area. In order to find percentage change, we don't need the actual volume or the actual curved surface area. We can use the assumed volumes and curved surface areas, the assumed values, to find the percentage change. Now there are quite a few methods to do this. I like the 100 method as the easiest for calculation purposes. So I'll make a table. I'll assume the radius to be 100 and the height to be 100. These are not the real values, assumed values, but that's fine because ultimately we want the percentage. The new radius is 80 and the new height is 110. Agreed? Now, volume formula is this and CSA volume formula is this. So, use this formula. The original volume I get as, whoa, that's like 10 lakh pi. Don't substitute pi. It'll be cancelled anyway. And the new volume is little less. It's actually only 7 lakh 4,000 pi. CSA originally was 20,000 pi, but the new CSA is 17,600 pi. Okay, now we are set. First, percentage change in volume. The formula is change upon original into 100%. That's a formula for finding percentage change of anything. Change in volume, the difference is 2,90,000 pi upon the original into 100%. Don't forget into 100%. Pi gets cancelled. 0, 0, 0, 0, 0, 0. 0, 0, 0, 0. Divide by 10, shift the decimal place. 29.6% is the answer. Similarly, percentage change in CSA is the change in CSA, there is a difference in CSA from the table upon the original CSA into 100%. So that's 2,400 pi upon this, pi cancel, 0, 0, 0, 0 cancel, 0, 0, 0, 0 cancel, 12% is the answer. Next, the 14th sum. Find the minimum length in centimeters and correct to the nearest whole number, so no decimal value, of the thin metal sheet required to make a hollow and closed cylindrical box. When they mention closed, it means it has a top ring and a bottom ring also. Of diameter 20 centimeters and height 35 centimeters. Given that the width of the metal is 1 meters. Actually, they've mentioned closed. That means the top portion is not a ring, it's a circle, and even the bottom is a circle. If they would have mentioned open cylindrical box, then it would have looked like this. This is open. That means you can put your hand through it. But they mentioned closed, so it would look like this. Of course, it has air inside it, so it's called hollow. That's okay. We are not looking at volume here. We're looking at the surface area, the total surface area. So when you buy a metal sheet, it will be in a rectangular shape. Then you fold the metal sheet, you cut the metal sheet and you make a cylinder out of it. When you buy the rectangular metal sheet, it has a fixed width of 100 centimeters. But what length of the sheet should I buy? See here. This is the metal sheet which I will buy. Then I will fold it and I'll make a cylinder out of it. So the question is, what length of sheet should I buy? Now we know that the total surface area of the cylinder, that's right, not just the curved surface area, but even the top and the bottom portion. The total surface area of cylinder, this is the formula for that, is equal to the area of the metal sheet. And metal sheet is rectangular, so it's length into breadth. Now we know pi value, radius, height also we know of the cylinder. We know the width of the metal sheet, there is a breadth, because when you go to the shop, the breadth is fixed 1 meter. You simply have to tell him how much length of sheet do you want. Breadth is fixed. So the only unknown variable here is length. So you get the value of length, 28 centimeters approximately, because the answer was actually 28 point something. So we have to round off to 28 centimeters. Even if it would have been 27.2, we would have to go for 28. Because we'll have to take extra material. We can't settle for less material. How will the cylinder be formed with less material? If some sheet goes to waste, there's wastage, it's okay, we'll throw it away. But we can't have shortage of metal sheet. And the cost of the sheet, cost formula is length into rate. Sometimes cost is area into rate, sometimes cost is volume into rate. So how will you be sure which formula to use? Well, look at the unit of the rate. It is mentioned 56 rupees per meter. That's the biggest hint. That is length into rate. If it was per meter squared, it would be area into rate. If it was rupees 56 per meter cube, that would be volume into rate. So the unit of the rate helps us to be sure of the formula to be used. But the rate is 56 rupees per meter and the length answer we got is in centimeters. Again, do not make the silly mistake of using 28 in this formula. Convert that into meters first. That's why I wrote 0.28 and then multiply by the rate to get the cost. Further, they are saying that 10% of the sheet got wasted because of cutting and overlapping. Obviously, so we should buy a little bit extra metal sheet. So the question is, how much metal sheet should I actually purchase? Which will be a little more than the TSA of the cylinder. They said that 10% of it is wasted. Of it means what? Of the original area. So I can say that the area of metal sheet required or to be purchased is 110% of the total surface area of cylinder. 10% extra for wastage. What's the TSA of the cylinder? Well, use the formula 2 pi r plus h and substitute the values, or just take it from here. It's actually 440 upon 7 into 45. This 100 came from the RHS, so ignore that. And now you solve it. Percentage means upon 100, you know that, right? Of means into. And you get the answer as this. Always try to get the answer up to 2 decimal places max. No need to solve till 3 decimal places. And a 0.1 difference is always allowed in the board exams. Next, the 15th question. 3080 centimeter cube of water is required to fill a cylindrical vessel completely, and 2310 centimeter cube of water is required to fill it up to 5 centimeters below the top. That means the total volume is 3080 total volume, and the bottom volume, this much, is 2310. But I don't know the depth of water here. All I know is that it is filled up to 5 centimeters from the top. So the actual total height we don't know. But one thing is sure, if I want to calculate this top volume, which is filled with air right now, it is nothing but the total volume minus the volume of the water. So that's what we are going to start with. The volume of the vessel, only the top 5 centimeters part of it, only the top slice of it. And by the way, even this top slice is a cylinder, isn't it? Think about it. If you cut it, the top part, it has a curved surface area, it has a circle on top. Imagine in a 3D way. So that is the difference in the two volumes given, which is 770. But volume of cylinder is pi r square h. Here r is how much, that I don't know. But height we know. 5 centimeters is the height of the cylinder we are considering right now. So solve and get the value of radius. Once you get the value of radius, then you can find the height of the vessel as well. We know that the volume of the entire vessel, formula is pi r square h, capital H now. R remains the same, which is 7 centimeters we found out. Total volume is already given in the question. So substitute the values and get the value of height, which is totally 20 centimeters. Now let me ask you a question. What was the depth of the water? It was 15 centimeters, isn't it? Although it was not asked. Roman number 3. What if it was half filled with water? Only half filled with water. That means to a height of 10 centimeters and 10 centimeters empty. Half filled with water. What is the wet surface area? We know the wet surface area is the curved surface area plus area of the bottom. The bottom is a circle, right? So, for this case, let's assume height to be 10 centimeters. So, area of the wet surface is the curved surface area. Remember, your height is 10 centimeters. Radius is the same, yes. Plus the bottom circle area, the base. Remove pi r common. Whenever you can remove common, you should. It will be easier to calculate then. Substitute all the values and we get the answer as this. Next, the 18th question. A circular tank of diameters 2 meters is dug. Circular tank of 2 meters is dug. Okay. Diameter 2 meters. From earth. And the earth which was removed, it is used to make an embankment, like a wall around it. And the thickness of that wall is 2 meters in width. And the height of that embankment wall is 1.6 meters. Find the depth of the circular tank. We'll have to draw a diagram to understand this. So look here. This is the earth's surface. This is a circular tank. Imagine 3D. It's a circular tank like this. It has a base, circular base. It has a height. Height we don't know. In fact, that's what they have asked. Depth. The diameter we know, 2 meters. They mentioned it. So the radius will be 1 centimeters. 1 meter, of course. That is 100 centimeters. Now whatever earth was removed from here, this earth, that was used to create an embankment around it. It was something like this. Let me draw a 3D image for you. So this is you. You are peeping into this. This is the wall to protect people from, prevent people from falling into this circular tank. And this embankment, which has a thickness, some thickness is there. How much is the thickness, by the way? Is it given? Yes, it is given that the thickness is 2 meters thick. So this material is earth. They are made up of earth. From where did we get this earth? From the earth which was dug up to create the circular tank. And the height of this embankment is also given, 1.6 meters. So it's very clear that the volume of the embankment is the volume of the earth dug out. Volume of this embankment, it looks like a hollow cylinder, open cylinder. So what is the volume of this cylinder, hollow cylinder? It is pi r1 square minus r2 square, where r1 is the big radius and r2 is the small radius. How much is the r2's value? 1 meter. And r1's value? Think about it. 1 plus 2, 3 meters. Okay, so this is r1 and this is r2. r1 is 1 meter and r2 is 3 meters, because the thickness is 2 meters. Thickness is 2 meters given in the question. Read the question again. And the volume of the earth dug out, it's a cylinder. So that's pi r square h. Again, pi gets cancelled. That's nice. Capital R, how much is that? What is the radius of this earth dug out cylinder? 1 meter. So substitute that. And the depth of this we don't know. So we solve and get the value of 12.8. So this is the answer, 12.8. That is the depth of the circular tank. Actually, if they would have asked what is the total depth, then we would have said 12.8 plus 1.6. But that's not what they've asked. They just asked the depth of the circular tank under the earth's surface. Next, the 21st sum. The sum of the height and the radius of a solid cylinder is 35. Okay, h plus r is 35. And the TSA is given 3080. Find the volume. Sounds easy. If h plus r is 35 and TSA is given, but TSA formula we know. This is the TSA formula for cylinder. Out of that, r plus h value we already know, 35. So substitute that. So the only thing left is r. Solve and get the value of r. Once you get the value of r, substitute and get the value of h. Once you get the value of h, find the volume using the formula. And this is the answer. But do all the calculations on your own. 23rd sum. A cylindrical vessel of height 24 centimeters and diameter 40 centimeters is full of water. Find the exact number of small cylindrical bottles, each of height 10 centimeters and diameter 8 centimeters, which can be filled with this water. Since the volume of water is same, we can say that the total volume of cylindrical vessel is equal to the total volume of all the cylindrical bottles. The formula is very straightforward. Number of bottles is equal to volume of vessel upon volume of bottle. It's always bigger volume upon smaller volume. Remember that. So we substitute the formulae. Pi and pi gets cancelled. R values we know. H values we know. So the answer is 60. Number of bottles. So no units. Now the 25th sum. The total surface area of a hollow cylinder which is open from both the sides. That means here the rings are there on top and at the bottom. It's open from both the sides. It's a hollow cylinder. The total surface area is given as 3575 centimeters squared. Fine. And area of its base ring is given as 357.5 centimeters squared. Height is also given. Find the thickness of the cylinder. By the way, thickness is nothing but capital R minus small r. Isn't it? That's what we have studied here. The capital R minus small r is the thickness. Here's the formula. So we have to find that. Let's write the data first. Area of the base ring is given as 357.5, but area of base ring formula is pi r square minus r squared. So pi goes here and I get the answer of r square minus r square, which is this. So far so good. By the way, this is r plus r, r minus r. Next, TSA. TSA of the hollow cylinder, again go back to the formulae, check it out. The external curved surface area, the internal curved surface area, plus the area of the ring at the base and the area of the ring on top. So 2 times pi r square minus r squared. This is the total surface area of such a hollow cylinder open. That is given as 3575. Now, you will be tempted to remove 2 pi common entirely. but leave this alone, because here we have all the values and here we don't have the values of capital R and small r. So only here remove 2 pi h common, so I get r plus r. The only unknown variable here is r plus r, so I solve it bottom mass rule. Be careful during calculations and get the value of r plus r as 32.5. Now you may think that you have r plus r and you have r square minus r square, but r square minus r square is nothing but r plus r minus r. Out of that r plus r value we know, so substitute and get the value of r minus r. So now you have r plus r as well as r minus r, both the values you have. Using simultaneous equations you can find the value of capital R and small r, isn't it? But why do that? They have not asked for that. They have just asked for the thickness, and the thickness is capital R minus small r. So that's 3.5 centimeters. That's the answer. Next, 26th sum. So here all the data is given, the height, the radius, the side of the cube. First of all, what is the total volume? That's easy. Total volume is the volume of the cube plus volume of the cylinder. Volume of the cube formula is side into side into side cube, which comes out to be 64,000 centimeter cube. And volume of the cylinder is pi r square h. Don't be confused between volume formula and surface area formula. Learn it perfectly. Here they have mentioned the value of pi, so you can't use 22 upon 7. You'll have to use this and get the answer as 62,800. And the total volume is 1,26,800 centimeter cube. But they also want the total surface area. Now here we can't say the total surface area is TSA of cube plus TSA of cylinder directly. We'll have to be careful about saying like that. When they say total surface area for a combination of solids, they're actually asking how much area is exposed. If I want to paint it, how much area will I paint? I'll paint the entire cube, but notice how this portion, the base of the cylinder, that I can't paint, isn't it? That's where the cylinder is stuck to the cube, so that will be excluded from the area calculation. What else? This curved surface area will be painted. What else? The top circle will be painted. Great. So it seems the total area is the total surface area of the cube minus the area of the circle plus the curved surface area of the cylinder plus the area of the top circle. So let's write it. 6a square, that's total surface area of the cube, that is the formula. A square is square, one square ka area, and there are 6 faces. Cube has 6 faces, so total area is 6a square. Minus area of a circle at the bottom, which we can't paint. But there is one area of the circle on top which we can paint, so it's getting cancelled. So ultimately we are getting CA square plus 2 pi RH, which is the same as saying the total area of cube plus curved surface area of cylinder. Interesting. Pi's value is given. Substitute that as 3.14. Substitute all values and get the answer in centimeters squared. Next, the 27th sum. There are 2 right circular solid cylinders. Right simply means that the base is perpendicular to the height. Not very important word in our calculations. They have radii in this ratio and heights in this ratio. Find the ratio of their CSA and volume. Okay, straightforward here again. Ratios are given. CSA ratio is 2 pi RH upon 2 pi RH. Here 2 cancel, pi cancel, R upon R is 1 ratio, H upon H is 1 ratio, which we know. Substitute the values, cut, get the answer in ratio. Don't leave the answer in fraction. Same way, ratio of their volumes. Well, pi cut, R upon R squared ratio and H upon H ratio. Substitute the values and get the answer as 6:25. Hi students, if you found this video useful, press the like button. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information.